Okay, this mini lecture is going to look at image formation in a plane mirror, and I've already drawn it, drawing vertically, and this particular situation is a little challenging. So I've drawn it, we're going to walk through it, and then give you some ideas about how images are formed in a plane mirror that we've already talked about in a previous introduction, but now you can see where they come up geometrically. So here is our optical axis, that's this line here. And of course, our mirror is here in the center. And again, that's that flat plane mirror. Our object is on this side. And it is a certain distance, the distance of the object from the mirror. Now we know that rays of light go in out all directions if this object is indeed a light source. They're going out in all directions, and one of those arrows is going to hit, one of those light rays is going to hit the mirror. And based on the law of reflection, our angle of incidence is equal to our angle of reflection, and so that ray of light, of course, bounces off. Similarly, if we look at a ray of light from the bottom, and I'm going to use one parallel to the first ray of light we just talked about, it too hits the mirror. If it's heading in that direction, hits the mirror, so that the angle of incidence is the same as the angle of reflection. That's our law of reflection. And it's going to bounce off parallel as well. So forgive the drawing. Now remember, our eye's over here, and so we're seeing the ray of light hitting our eye. And it's those same rays of light as if I extend that ray back, the object, so this ray of light, remember, represents the top of the arrow. This ray of light represents the bottom of the arrow. I can recreate, this is my image. It's as if those rays of light were coming from an object on the other side of the mirror in this location and of that height. Now, what do we notice? First thing we notice is that the object image, is upright. And remember, an upright image means it is virtual. We're not really seeing an object on the other side of the mirror, right? Our brain is interpreting those rays of light as they hit our eye. So upright image, it's virtual. Based on the geometry, the image distance and the object distance are the same. And we talked about that when we were just conceptualizing sort of how things look in a plane mirror. Furthermore, the height of the object and the height of the image are also the same. And so you can kind of see the geometry. You can look at similar triangles. If you want to flesh that out a little bit more, you certainly can. But I want you to get an appreciation for how the rays trace in order to form that image of a object in a plane mirror. Now, we could have chosen any angle of light from that top of the arrow. So if I would in fact choose a different angle of incidence, we of course have to look at the angle of reflection. It's almost the same. And if I extend that ray back, you'll see that they too will intersect at that top of the arrow. Again, this is representing the top of the arrow. So it doesn't matter which one you choose to form that image, understanding that to help us form that image, a parallel ray of light certainly is going to be beneficial. All right, so image formation in a plane mirror using ray tracing and noticing our properties of image formation in that plane mirror. And of course, since the object and the image are the same height, the magnification is 1. So just to kind of close out all the properties of image formation that we've been doing in lenses and mirrors. All right, good job.